All right. Well, I am very excited about our speaker this afternoon, Dr. Lennon Rodgers, and he is the director of the Makerspace at the University of Wisconsin-Madison. And he's going to walk us through information about his background and his experience, as well as the Makerspace at UW-Madison, and all that it can bring to the College of Engineering, as well as to the community. So thank you very much for joining us today, and I will turn it over.
All right. Okay. So as Laura mentioned, I work in the College of Engineering, and the overall name of the organization that I run is called the Granger Engineering Design Innovation Lab, and I'll go into a little bit more detail of what that is. It's a little bit more than the Makerspace, actually a lot more than Makerspace, but that's kind of a key piece to what we do. So here's just a brief outline. I'll just talk for 20 or 30 minutes, and then I really hope to open it up because this is kind of a general talk, and definitely welcome to answer any of the questions you have, or even just hear any of the thoughts, because you guys might have some unique experiences. So I'll give you a little overview of making at UW-Madison. So it's about our overall vision, what we're doing, and then some of the facilities and resources we have in general. And then just for this talk, I kind of collected some of the more historical, broader maker movement discussion topics. So that's what Laura said was maybe you guys were interested in. So a little bit of the historical context, some of the modern influences, and some of just the focus elements as part of the maker movement. All right, so I'll just start with a general overview. So what our mission is in terms of in the College of Engineering at UW-Madison, and you'll see a lot of these aspects, I think, in a lot of makerspaces, especially the ones in higher ed. But hands-on learning is key, so we're trying to bridge the gap between the theory that primarily engineers are learning in their courses and some of the applications that they could use it for. Student empowerment, so empowering students to design and prototype on their own initiative. So it's not things that are mandated by the curriculum necessarily, but they have a little bit of freedom to do what they want. Peer learning is another key thing. So I'll talk a little bit more about it, is that it's a student-run facility, the Makerspace is. So it's really students teaching students. If you come into our Makerspace, you probably won't see me, and you won't see, actually the guy that runs the Makerspace, he's an industrial designer. You probably won't see him either. You'll see a lot of students, and that's what we want. So that's that peer learning component. So another thing that we foster is a diverse community, and I think you'll see that in a lot of Makerspaces. So it's a welcoming community. It just enables collaborations, and it's just very diverse in terms of gender, race, and disciplines, ideas, interests, that kind of thing. Design innovation is another part of our mission. So I'll talk a little bit more about this. It's kind of tied to some of our programs. So it's essentially a hub for designing and prototyping innovative products that satisfy some type of need. And I think that's kind of relevant to what we'll talk about today. And then the final thing is that we provide open access to technology. And so our Makerspace facility is located in the old engineering library. All the books are gone now, and it's not a library, but we wanted to preserve that same sense of open access to resources. And so that's what we do through this aspect of our mission, which is just offering an expansive library of technology. It's tools and equipment, and so I can show you some of the pictures, but a lot of what we have is in the back that students can check out. So just the overall high-level vision. What we're trying to do is create an interdisciplinary pathway around design and innovation. So we have all kinds of things. I won't go into all of these, but this is just to give you an idea for some of our very high-level vision and some of the programming we have at the Makerspace. But we have pre-college programs, we have first-year programs, we have competitions and programs, we have capstone design courses, we have what's called a certificate program. Probably the two that are most interesting, which I can give more information are freshmen, these first-year interest groups and these freshman design courses. And then there's the capstone courses and then the master's degree. And those are oftentimes around some type of need or opportunity. And so I'll provide Laura with some contact information if you're interested at all in working with some of the students through those courses. The volume is so high. I mean, at UW-Madison, it's over 5,000 students in engineering around that. And so the number of projects they work through every semester is just huge. And so we support a lot of those different discipline capstone courses. Just to mention with the master's degree as an example, so we're creating this master's degree. It's an interdisciplinary degree between the College of Engineering, the business school, the art department, something called the iSchool, which is more information sciences, and the School of Human Ecology. And so there's five schools and colleges, and it will be a 1-year accelerated master's degree, and it will start a year from now, and we will house it in our facility. And these are just some pictures from a course that we ran to prototype the program last summer. And so the students focused on farm to table, and we had them go around and look at the different farmers markets and identify different opportunities. So they really learned that human-centered design process. And so that's what this is about. This one we taught in collaboration with the College of Engineering, which is where I am, and the School of Human Ecology. But like I said, the master's degree will be all 5, so it'll be very interesting. So in terms of facilities and resources, what we have, so like I said at the top here, that's the overall organization. It all started, and I'll give you a timeline, but with a gift from the Granger Foundation, which oftentimes helps, as you guys will see. That initial gift is critical in a lot of ways, but it's not essential. But in terms of facilities, we have the Makerspace, which I'm primarily talking about. We have a machine shop called Team Lab, and it's actually equal in size and in volume, and it's super impressive. And then we also oversee some of the shops used for the student orgs. So that's the student organizations, student clubs. Those are some automotive teams. There's some biomedical engineering type teams, which would be similar to what you guys, the areas you work in. And then on the program side, we have a whole set of programs that I mentioned earlier, but those are more about the master's degree and capstone projects and things like that. So that's what we have around this initiative called Cross-Disciplinary Design and Innovation. But just to give you a timeline, if any of you went to UW-Madison in days past, there's been a machine shop for a very long time. Here's the more recent history, is that in the 90s it was consolidated. A lot of universities you go to, and they have different machine shops all over campus. That's kind of what I experienced through undergraduate and graduate school. But then in the 90s here, they consolidated them. Now it's called Team Lab, and that's the machine shop, and I oversee that too, but there is a whole team of people, and I'll show you that in a second, that run that. But kind of moving forward in 2015, that was the gift. 2016, they renovated the building, the engineering library, and then 2 years ago, essentially, we opened up. And so pretty much, if you come and visit, which you're all welcome to, this has all been created in the last 2 years. 2 years ago, I lived in Boston, and I moved here, and that's kind of what we've done since then, what you'll see. So in terms of just staffing, and again, this is just our case, just to give you an idea, it's not what you need, because it's probably among the largest scale that you'll see. But full-time staff, we have 11 full-time staff total. We have 63 student staff. It's quite an army. And in terms of square footage, just in the shop spaces, it's 24,000. If you include everything, it's almost like 50,000. So it's a lot of space. And it has to do with the volume of students that we have come through our facilities. So the machine shop, as I mentioned, that's called Team Lab. I'm not going to talk a lot about that because I think we're mainly talking about benchtop digital fabrication. But we do have Team Lab, and it's integrated all throughout the coursework. It's mainly metal work, mills, lathes, welding, that type of equipment, which I think has been around for part of the Industrial Revolution, essentially. And that's the website there. And these are just some of the equipment. Like I said, more of the traditional machine shop, which is essential for a lot of things, but not everything. And then here's our staff. So there's 8 full-time staff. These are all machinists. And so this is a whole nother discussion about staffing and this kind of thing. And then the Makerspace, as I mentioned, it's largely about all the things I talked about, peer learning, do it yourself, and I'll go into more. But it has to do with this is the equipment that we have here in the Makerspace. So the breadth is quite wide. So even though the breadth in a machine shop is quite narrow, I think one of the things you'll see in a Makerspace is that there's no real narrow definition of what you can and cannot have in a Makerspace. So we have everything from 3D printers to drones to data visualization, augmented virtual reality, 3D scanning, and so on and so on. There's a lot of different technology, and I could talk about any of these if you want, of like, why would I want that, or I'm interested in this. It's an interesting discussion to have. But it really depends on what area you're interested in, and also above all, probably your budget in a lot of ways. But the good news is a lot of this stuff is consumer grade, and it's really not that expensive. So that's good. As I mentioned, it's a student-run facility, which is a really exciting aspect to have. And so it's run by about 30 student staff, though it's overseen by a shop manager that I mentioned, the industrial designer. And here's just a few pictures of our facilities. It's not showing everything, but it just gives you an idea. We have a little bit of a 3D printer area, a little machine shop. There's some more. This is a router for cutting wood and some metal. And then we have an electronics area. But there are a lot of other areas too. Photography booth and some classroom areas. One of the things that we looked at is just how the Makerspace is having an impact on the number of students coming into shops. So what we did is we counted up the number of students coming into the shop, just a machine shop, in 2016, and then we compared it and tracked it as we added the Makerspace in 2017 and had it open in 2018, 2019. So over 2 years, we essentially saw, we saw a 4.6 times increase in the total number of people coming into the space. That was a 7.7x of women coming in, and targeted minorities was 6.8. But it gives you an idea of the volume here. We're talking 36,000 people walking through the door. So that's why our spaces are so large, is the volume is quite high. And you can see the same trend here if you just look at men and women, is that this is after adding the Makerspace. So this is before the Makerspace is the blue on the left, and then the first year the Makerspace was open is red, and then the orange is the third year. So as we added the Makerspace, I think largely for a lot of different reasons we could discuss, the volume is increasing even more, which is what we want. One of the key things at the Makerspace, which I highly recommend if you do create any type of facility, is to have very informal workshops. And so that's a lot of our activity. So over the last academic year, that's the fall and the spring of this past year, we had 150 workshops in the evenings. So these are taught by our student staff. They're created by our student staff, and they're on different topics. This is visual overload here, but it's everything from 3D printing to some more hardcore engineering stuff like finite element analysis, laser scanning, electronics. There's all kinds of topics. And essentially, we leave it completely open to the student staff to decide what they want to teach. We just say it has to be about 1 hour, and it has to be targeted towards people that are new, not experts. Every once in a while, we'll have more an advanced topic. But these are about our workshops, and these are just some pictures from some of the events that we've had. And we have different types of events, and I could discuss that in more detail. But anything from more artistic side all the way down to more traditional engineering, but we try to have a little bit of a split, like 2/3 engineering and 1/3 outside engineering, because we've observed that students really like more of the artsy projects, which are good, but it's not really super core to our mission. So we try to have a balance there. Okay, so that was kind of it. That was just an overview, like I said, of our vision and our mission and some of the facilities and resources. And I could, hopefully we'll have time at the end. I can answer any questions you have. But now I think this might be more of an interesting discussion because it kind of gets outside of our specific space. In our specific space is not actually the norm. I think there are a lot of different quote-unquote norms, and we're in the more higher ed, larger budget, larger number of students that we're servicing. But I wanted to just go through a few just broad points about historical context, some of the modern influences, and some of the focuses of the maker movement. And I did a fair amount of literature searching for this, but a lot of this is actually just some things that I've observed, and I could tell you more about that. So this is not to capture everything, but I just went through after reading a bunch of journal articles and even some in popular media and said, okay, what are some of the historical context things? And each of these could be talks in of themselves, so I'm not really going into detail. But let's just look at some general historical trends. So industrial arts that used to happen in middle and high school. I had it when I was in middle and high school. Tinker toys, erector sets, radio clubs, and Radio Shack, popular mechanics. These are all things I think people associate historically with making. There were also a lot of products that could be fixed and customized. There's like the whole muscle car movement. There were the Apple II computers. People used to make their own clothes and things like that. So that's all kind of the historical context. From a modern perspective, I think we saw a decline in traditional manufacturing jobs, as a lot of people have written about. We saw an increase in mass-produced, they're not all made in China, but they're the plastics entering the industry. There were a lot of other things that made much more integrated designs that were not like muscle cars and other things. They're much more difficult, much more complicated, and they were not meant to really be serviced like some of the older products. We saw a decline of industrial arts in middle and high schools. At the same time, on a positive note, there have been these consumer-grade digital tools, 3D printing. There's been a desire for innovation entrepreneurship, and this desire for diversity of STEM fields. So this was just kind of the summary of some of the modern trends that I observed. I went out and read some of the papers, and this was a list that was put together by a person that wrote a paper called Maker Movement in Education, History, and Prospects. They're kind of similar, so I'm kind of repeating myself in some way, but you'll see these common trends, and in the next couple slides, I try to summarize these trends more categorically. So this is taken from this paper, and the author saw kind of 5 different trends that are leading to the maker movement. So the first was pedagogy. So it's really this is just literally how he worded it himself. So societal acceptance of ideas of progressive and constructivist education. So that, to me, that is what I interpret as just a rethinking of education, is kind of going back, and the time is ripe for reevaluating education. So I call the next one economy, but how they described it is countries looking for the innovation holy grail. So I've been part of this in some ways. So 2 of the makerspaces that I helped make were international. So one was in Singapore and one was in Russia, and both of those kind of had that, I would say, had elements of this, where it was government funded, and they really were looking to stoke the economy and try to get more entrepreneurs and innovation out there. So that's kind of that second point. The third is just the open access. So things like coding that was open source. I go into a little bit, but YouTube, there's all these web services that come online that enable this open access to information and tools. So the cost of tools was the 4th trend, so dramatic reduction in cost of digital fabrication. And I actually think the last one's kind of very related to the 4th one, but it was better tools and research from academic labs. And actually a lot of the low-cost tools, not a lot, but some of them are kind of mixed with academics in some ways, is that they kind of spun out of grad students' efforts and things like that. Okay, so here are just some interesting early influences, more recent though, I would say, for the makerspace movement. So in terms of facilities, there was a thing called the Fab Lab Network. Has anyone ever heard of that? It's kind of it's kind of one of the oldest one. It was started in 2001. And it's actually a guy that I've worked with at MIT. His name's Neil Gershenfield. And he started this thing called the Fab Lab Network. And there's a whole TED Talk on it. It's very interesting. But that was one of the early ones. And he was really about, he actually kind of had 2 facets to his mission. One was enabling local people making products unique to their local needs, I would say. And then the other part was more of like customization of things. So the consumer of one, you want something for yourself that has this very specific design, you can make it yourself. So that's kind of one way to generalize. So that's the Fab Lab Network. It was actually very successful, and they're all over the world, so you could check that out. Probably one of the distinctions there is that they specified the equipment that you needed to buy in order to be part of the Fab Lab Network, because then they wanted everyone to be able to share plans, and they all would have the same equipment. So that was kind of that, and I think that's kind of changed. Tech Shop was like a startup, more commercial effort. So the first one was a little bit more academic, I think initially funded by NSF or some government organization. The second, Tech Shop, was more of a startup, and that was started in California, and then they expanded, and there's a whole history, but now it's not here anymore. Okay, so that's facilities. Those are some of the, what I'm calling the early influences. These are things to look up if you're kind of interested in where some of it all began. So in terms of media, Mythbusters is kind of an interesting one. That came online in 2003. To me, that has a lot of similar DNA to the hackerspace movement, and we can go into more of like what that means, but there are a lot of other spin-off shows from that. I don't know if you guys have you guys ever seen any of those, like even beyond? Yeah. I was oddly randomly on one of those shows at one point. The one I was on was called Catch It Keep It. It was on the Science Channel, but it was very similar, and it was like very popular. The one I was in was in 2010, but it was all about people working together, trying to beat the system or trying to break a myth or something, but using hands-on knowledge to build these type of one-off prototypes. So Make Magazine was 2005. They actually just went bankrupt. I don't know if you heard. But that is a magazine that also has maker fairs, which I go into a little bit. But that was someone that it's really started with the media side and then got into the maker fairs later on. So Instructables is another kind of media thing that happened. Again, you're noticing this 2003, 2004, 2005. It's like all around this time. So Instructables was started by a grad student at MIT actually, and it was a forum for people to post instructions on how to do things, how to make things. YouTube was a big thing, 2005, as you know, and you'll see even in terms of Makerspaces, is that how many YouTube videos do you have to watch sometimes in order to get to the good one that really shows you the right way to do it. And it really, just globally, I mean, I've watched ones from random people in Russia to somewhere in Georgia, and it's really democratizes the aspects of DIY. Okay, so in terms of marketplaces, when I was thinking about this, I thought, oh, there was eBay and this kind of stuff. But eBay was, you could sell your coins. I think it was originally to sell Beanie Babies or something like that, was his wife's Beanie Babies. But what I focused on here were really things about DIY, things you make and then you sell. And that's kind of what the two primary ones I could think of, and I'd be interested if you have any other thoughts, was Etsy, which started in 2005. That was about making something yourself and selling it. And then Kickstarter, which was more recent, which is about crowdfunding. So in terms of events, the Maker Fairs, which I think will continue even though Maker Inc. went into bankruptcy, but they have one in Milwaukee. They have a mini one in Madison. But these are opportunities for people to come together and really be part of a broader maker community. The second one is what's called, you guys probably haven't heard of this, it's called the International Symposium of Academic Makerspaces. That's held each year in a different university. So the first year was at MIT, the second year was at Case Western, the third year was at Stanford, and this year it will be at Yale. And there are a lot of people from primarily higher ed, but they go all the way down into probably high school. And like I said, primarily for higher ed, but they look at these different topics around academic makerspaces. So in terms of legal trends, I'm not an expert here, but there's just a lot of activity around open sourcing, and that's really helped a lot with the maker movement. And then finally, which is super critical, is just the low-cost, easy-to-use tools. So Reprap was a 3D printer that came online in 2005. Again, that was a tool, but it was also made at a university in Europe. So that was a very low-cost, open-source, DIY-type 3D printer. And then Arduino came online in 2008, and that's a small circuit electronic microcontroller that you need to pretty much do anything electronic in terms of maker-type projects. And I kind of lived through all this, so it's kind of interesting for me to see this. I was, an undergrad, kind of going through grad school all this time, and I saw my first 3D printer in grad school and that kind of stuff. So that's what I call the early influences of the maker movement, were kind of these different pieces of what was going on. If I were to generalize in terms of different flavors or foci of the maker movement, I think most spaces could fit into one of these categories. So there are kind of three key categories, and this is in some ways similar to what that author of the paper put together. He had 5 different trends, but mine were more like buckets that you could put different types of maker spaces or hacker spaces into. I feel like they have one or more of these type of focuses. So it'd be empowerment. So that's more the DIY. And so that's practical life skills, and that's kind of has some roots way back to the industrial arts in some ways. But so that's kind of one part. The next is solving unmet needs. So that's with more of a grassroots approach. So could be locally, so local people solving local problems, and I think that's a lot of what you guys would be working with. It could be national or global, so that's larger markets. So maybe a small group of people, but they're looking to larger markets. The next part is just customization and personalization. And again, Neil Gershenfeld at MIT, that was a big part. That's like the consumer of one, that's you, that you're building it for. Open source, teamwork, community. Those are kind of all themes, I think, related to empowerment. The next one is just digital prototyping in micro factories. And this is really just a continuation of what engineers and designers have been doing for a very long time. So a good example is M-Hub in Chicago, which is really more of like a micro factory. You could call it a makerspace, but they're really, part of what they're doing is really a micro factory. So it could be prototyping just as part of the design process. It's nothing new. People have been designing things for many, many, many years, but now you have these different types of facilities. Related could be more of a focus on entrepreneurship and innovation. Again, part of the design process, quick iterations and doing small production runs. And then finally, the third one, which is probably the one that I'm most interested in, and I think it's one of the least understood in some ways, is the hands-on learning part. So it's when you're using a makerspace or something like it, and it's whatever your use is rooted in educational pedagogy. It could be connecting theory to applications, creativity. There's a lot of different things that it could be connected to. But the only point is, I think that for you guys with assistive technology, I think it's largely about that solving unmet needs from a grassroots effort. From me, we actually kind of try to strike all the strings, as you could see in our mission statement probably. But I think there's a lot of opportunity for higher ed in this hands-on learning, and it's not really quite solved, but it may not be relevant for you guys. So that's kind of it. I went over kind of the broader movement of the Makerspace, but I'd be happy to open it up for discussion or any kind of thoughts or questions you guys have. Yep. Yep. Primarily, it's people at UW-Madison. That's kind of how we advertise it, but it's anyone at the university. Yep. Take a tour? Yeah. And I'll send a list of Laura of a bunch of different links. And one of the links could be that, like if you're interested in taking a tour. It's open pretty much 10 to 5 during the summer. It's open more during the academic year. But you're welcome anytime, and it's on our website. I'll send a link. Yep. But the other link I'll send you guys to is just some contact information if you want to suggest a project or something like that for the student projects, because a lot of times they take on projects. If you have an idea and you have a client, they typically want to work with a client, like some specific need, and that's kind of that one right there. That's some of the courses. As long as you have a client, that's kind of their typical requirement. It's not just like I have an idea. It's like I actually have a need, or someone that I know has a need. I know a lot of people have a need. The student has to be able to go and interview that person in some way. Either they could probably do it remotely, but ideally they would actually go to the person. And a lot of times they're biomedical engineering students, but sometimes it's all over the place. Oh, yes, there are different, like, I don't know all of them, but you're talking about for assistive technology? Okay, I'll do a couple hashtags. Hashtags prosthetics are very popular. Everything from people to cats. We did one for cats. I don't know if you've seen the local news, but there was, what was the Stubbs? If you haven't, check it out. The Stubbs was a very famous cat. But they've done it for people too. They've made a lot of prosthetic hands. There's a group that does that. We have 3D scanners and other things that can kind of cast part of the arm and then scan it and then build around that. They've built custom swings. I think last semester was for someone with that needed a special type of swing. They needed some ramps going up to their bed. You know, these are the kind of things, lifts. But that course in particular is freshmen, so it's not super complicated. Yep, in the back. So I'm not the sole source for the information, but I do teach one section. We're having a theme on Africa this semester, so we're not doing more of a general theme. But I don't think that there is in general, but I recommend having some bit of money just so students can make, otherwise they're using scraps of stuff, which really limits their experience and their ability for impact. So yeah, there's no set fee, but it's just normally for materials. So it's like hundreds, maybe like $100 or $200, something like that. But I don't know for sure. That's typically what I give my students, usually like a $200 to $300 budget, and it's a group of 5. Yeah. Yep. Yep. Yeah, my understanding is that they then give them, but they're not necessarily ISO 5000 tested or whatever the standard, these are freshmen, and the instructor tries to set those expectations. But I think the students would be really good at idea generation. I mean, they are really good at it in general, kind of evaluating the possible options, and then down selecting and doing a rough prototype. But I do think that sometimes they are used, but I wouldn't personally recommend it. Yep, in the back. So if you're in a local community, where would people get money? Like, what are some funding models? Yep. I mean, I can just tell you what I've seen personally. I mean, I've seen them in libraries, so that kind of comes through that funding source. I've seen them, like, in an extreme case, I mentioned M-Hub. You could look that one up. That's a huge one in Chicago. But that's more, they got some local government money, and it's more trying to be self-sustainable, though. They charge fees for using the facility. There's one locally here in Madison called Sector 67, and it's a community maker hackerspace, and they have fees that they charge. So we have, like I said, we're kind of an odd case where, not an odd case, but we're tied through tuition and through other things. So I'm not really the super expert when it comes to how do you fundraise for that kind of thing. But if you're at all interested, I could try to connect you with some other people that have done that. And I think you don't need a lot of money just to start. I mean, I think most of the machines are from the few $100s up to like $1,500. You can buy most things in that price range. And then 3D printing and other things, it's just the material cost and maintenance. And I actually think that the maintenance and all of that is the more complicated question, which I won't answer it in an unsolicited way, but you can buy all the equipment you want in the world and it'll all break with time. And it's really, that's why I'm a little biased that you need someone that's more on the engineering side there, because just the amount of maintenance that's required. You don't have to have a degree in engineering, but someone that's interested in the maintenance of the machines. Because even though they're cheap, well, I mean, I guess because they're cheap in some ways, they need a fair amount of maintenance. So it's just good old changing the air filter in a car or in a furnace, this kind of thing. It's that level of maintenance, but you have to do it. It's not like you just leave it there and it doesn't take care of itself. Yep. Wow. I can't believe you remember 4 weeks. All right. Yeah. Yep. Oh, all the different. Yep. Yeah, and I think there are different flavors. I mean, in the upper right-hand corner, I call them traditional shop tools. These are things that you can essentially buy at Home Depot in cheaper forms. Ours are a little bit more expensive, some of them, just because the amount of use that we get. But you could go and buy Ryobi at Home Depot or DeWalt and this kind of stuff. So that's kind of the upper right-hand corner. Those are non-digital based tools, so you just like in the old wood shops, you just cut manually. And then here's just electronics and circuit board fabrication is kind of in the middle. And again, those you can buy pretty cheaply too, just 50, 100, 150. Ours are quite expensive because they're tied more to engineering curriculum. And I think most people want their engineers trained on industry quality stuff. The next one, third in from the right, is just what's called CNC, computer numeric control, or computation numerically controlled, computationally numerically controlled. And so that's basically taking a design from the computer and cutting it out in the physical world. There are a lot of different tools. So, and one is called a router, and that cuts primarily in 2 dimensions. So it just cuts sheets of wood or plastic. It can also cut in the 3rd dimension. But we have a water jet, that's the one on the right, and then we have a laser cutter. They're all for the same idea. They cut sheets of material into different things that you design on the computer. Then I mentioned 3D printing. I had a picture. We have a lot of 3D printers now. This is an old picture, but we have racks of, it's like 30 printers or something like that. So we're a little factory of 3D printing, mainly because just the volume. But there are different types of 3D printers. Ours tend to be about the $5,000 to $10,000 printers. You can buy them down into about the $1,000 or below. But we've chosen these that are like the $5,000 to $10,000. We have one that's more of like the $50,000 variety that, but we mainly use these. We have drones, so those are for students can program them to do various things. Data visualization, that kind of goes with augmented virtual reality, 3D scanning. This is all in a space that we have that was part of a gift from the Kohler Foundation. And so it's all about scanning things or working with things in the virtual world. And then you can print it if you want or do other things. But you can scan things, that's a 3D scanning. So you take this little wand and you can scan something, bring it from the physical world into the virtual world. And then augmented and virtual reality is wearing those headsets where you feel more immersed in a virtual environment. We have a little bit of robotics. Some robotic arms, not much. And then we have a few sewing machines for textiles and things like that. Yep. So yeah, robotics and machine learning. So that's, again, kind of more specific to engineering. That is printed circuit boards. So that was the circuit boards that I mentioned. And then CNC is the computer numerically controlled. So that's just like computer. It's like a 1980-something term. Yep. Yep, and VR, AR is virtual reality, augmented reality. So it kind of depends on what you're doing. You can do a lot with certain machines. So if you have any questions about that, I'd be happy to answer, based on what you're doing. But a 3D printer is very useful, and then we find the laser cutter to be very useful. You can buy a laser cutter for a few $1,000s. Ours is that red one there, but that's like a $50,000 one. But again, we're at a different scale in general. We're not industrial scale. That would be even more, but we're kind of in the middle. We're training engineers to kind of move into that scale. But you can buy a laser cutter, which a laser cutter is a cutter that uses a laser. It just cuts with a laser, and you can cut sheet goods of plastic and wood. But it's really good for prototyping based on computer-based designs.
So we will send out a link with some resources as well as how to book a tour. Yep. And you also have a virtual tour, I believe, on your website. Is that correct?
Yep. We have a bunch of pictures, and with a 360.
A 360 walkthrough tour is available on the web.
You could put a headset on and go through it.
All right. And I do know that at UW Stout there's a Fab Lab, and I know that we used to work with students like in the industrial design. They would all be given the charge to come in, similar to how your freshman students are, yep. Is to identify with one consumer, identify a solution for that consumer. So in your packets is a list of the Makerspaces, and they're done by region of the independent living centers. And those, there should be a disclaimer on theirs there because they are subject to change. But that is the current list of Makerspaces throughout Wisconsin that are divided up by region. So I would encourage you to book a tour or contact some of your local Makerspaces just to get a little more idea of what's available in your area. And then after our break, we actually did a video tour of the Makerspace in Milwaukee that we'll be able to share with you. And then I also have a video of what it takes to make your own Makerspace. And so we'll be sharing those before some hands-on time. So any other questions for Dr. Rodgers? Well, thank you very much for your time. This has been great information. Thank you.